Hello everyone, this is our process control lab. So first of all, this is our first video. So we will start with our introduction with a very popular software which is used in our process control industry or a process control application. Not only process control, a lot of applications are there where we can use this software, which is called as MATLAB. So the introductory part I will discuss here in this video, and then we will go further with our experiments one by one. So in the first video, let's start with the introduction with MATLAB and Simulink tools. So basically, what is MATLAB? MATLAB is a software which is developed by MathWorks in the late 1970s, right, which is called as Matrix Laboratory. The abbreviation of Matrix Laboratory is MATLAB. Here we can construct various processes or process models. Along with these various algorithms you can generate also using this MATLAB. Under this MATLAB, a Simulink is a part by using which under this Simulinks various basic blocks are there. By using those blocks you can create or construct any process models, right? So first of all, what is MATLAB? MATLAB is a proprietary programming language and numeric computing environment which is developed by MathWorks, as I have told just right now. It is developed by MathWorks and was designed by Clive Moller in the late 1970s. So for various versions of MATLAB, after another, updated versions has been launched. So slightly difference you might get while working with this software, but the basic thing will be the same. So it is a programming platform which is specially designed for engineering applications or for research purposes to analyze and design various systems and the products that transforms our modern world. So using this MATLAB, we can analyze data. Three basic things are there that we can do using MATLAB is analyze data. Second one is develop algorithms. For whatever you want, you can generate or develop any algorithm using few commands, and create models and applications. So here Simulink tools comes under that part, create models and applications, right? So this is the basic idea of MATLAB. What is MATLAB and what is its use? So let's go for Simulink. So what is Simulink? Simulink, it is basically used to model, analyze or simulate dynamic systems using various block diagrams. So various basic blocks are there in Simulink. A Simulink library option is there. Whenever I'll show you in the MATLAB after this introduction, you can easily come to know that what is Simulink and what is Simulink library tools and what are those tools and how these tools are used for creating various models or various block diagrams for a process or for a system. So Simulink is basically a graphical representation. You can build a model or block diagram by dragging and dropping various blocks, basic blocks, right? So it is very easy to use, and it allows the users to concentrate on the structure of the problem, basic structure of the problem, rather than having to worry about programming languages. In this Simulink tools, you need to just model the process or the system using those blocks. So you need to focus mainly on the structure of that problem, right? So the purpose is we simulate, the purpose of simulation is nothing but we simulate a model to study the behavior of a system, right? Whether the model is correct or not. For a real-time process, first of all you need to create a model, and you have to observe or check the output of that model, whether it is working properly or not. This is the basic idea of Simulink. So now, how to launch Simulink? Click the new model icon. Whenever you will open the MATLAB, a new model icon will be there. You need to just open that new model icon. It will appear in the upper left corner, as it is mentioned here, of the Simulink file. Then create new model, a file option will be there, and then new, and then model. So you need to just open that model. In various versions of MATLABs there are slight difference, but you will easily understand those things whenever I'll start with the MATLAB software. These are the various building blocks. This is Simulink Library browser. As I have mentioned earlier, there are various options like sources, sinks, signal routing, signal attributes, ports and subsystems, model-wide utilities. So all of these are not necessary for the basic programs or basic simulations for our process control applications. Very few we will use, which comes under the continuous block, discrete block, and sinks, sources. Very few basic blocks are there which we will use. Those comes under these 3 or 4 options. I'll show. Let's go further. Next, yes, sources blocks. I'm just going to discuss about these 3 or 4 categories of blocks. Sources are only having output, signal generators, constants, etc. Sinks, those are inputs. Scope, that means the output, wherever you will observe the output of the system or the graphical representation, that will require the scope block. And then workspace and continuous signals like integrator, transfer functions. These are continuous signals. Discrete means discrete transfer function. If I require, then you can go to the discrete option, and then there you will find out the discrete transfer function. Delay, unit delay, memory, like this. And math operations, some basic math operations like gain, product, sum, trigonometric functions. These you will find under this math operations. And after that, user defined functions like S function builder. These are user defined. Whatever your application requires, you can build this, right? For some electrical applications, SimPowersystem option is there. As I said earlier also, for various updated versions of MATLAB, this nomenclature or these abbreviations may differ slightly, right? But the whole construction will be the same. SimPowersystem, it contains electrical blocks, electrical sources, machines, measurements, like this. So in process control, basically we need not to require these blocks, the basic blocks. We will require these 3 or 4 types of basic building blocks, right? So next, it is step signal, which comes under the source. Then sum block, which comes under the math operations. Then transfer function, which comes under the continuous block. PID controller will be there, because in process control applications, controller is a must. So it comes under the continuous block. Then transport delay, which comes under the also the continuous block. Integrator is there, scope is there, then derivative, marks, constant and gain block. These are the basic blocks we can build, or we can make any process control models for various processes using these basic blocks, right? So whenever we will open the MATLAB, I'll show each and every block is having its information inside this block, so we can easily get those brief idea of those blocks, what is the function, basic function of these blocks, and where it will require, where it is required. And then here you can see whenever you will open these building blocks of Simulink library, suppose step is there, you just right click, help for the step block, just click it and this window will appear. The description of step block, it will appear here, library Simulink sources. That means step is nothing but comes under the source block, right? And the description of that source block is there, in which applications and where we can use those step block. This is step function, that means an input. Naturally the step input, about that step block you will get the information here. And similarly you can open these other blocks also and see the description on this window, right? So let's go with the MATLAB and I'll show how to create a Simulink model using those blocks by dragging and dropping and connecting those blocks with one another, right? Let's go with the MATLAB. So this is our MATLAB window. Whenever you open the MATLAB, the window will appear like this. The MATLAB version I have installed is MATLAB 2018A. 2018A version I have installed. So this is the window first which will appear in your desktop after opening the MATLAB. Here it is, the Simulink blocks. You will find out those Simulink tools under this block. Just click and here blank model is there. You need to select this blank model. Whenever you will select, window will appear like this, named as untitled. So you can change the name while saving this Simulink model. So here you can see it is a blank model. Here library browser is there, so just click on this browser. This window will appear in your desktop. As I have mentioned the various building blocks you will find out here. So continuous, sync, sources. So first of all I'm showing you the sources. Whenever you click on the sources, this will open. Various signals like band limited, white noise, like clocks, constants, counter free, like this. So basically we will deal with sine wave, step signal, like this basic signals, or signal builder or signal generator is also there. Whenever required you can select these blocks. So how to drag and drop and create a model I am showing you. Just click this, drag it here, and your step block will appear in your sheet. And then suppose sinks contains, as I have mentioned, the scope wherever you will observe or check the output of your process. So you will get to observe the output in the scope block. Just connect these two blocks. This is the time, for what time you are going to run, the run time. Here it is 10 seconds. You can change it 20, 100, 200, 150, 500, whatever you want, for how much time you want to run this, or you want to display your output in the graph, right? So I am giving it 100. You need to save first before running the program. So I am not saving it, I am just showing you. Click to run. This is the run option. Just double click in this scope and you can see step signal having amplitude 1. Why it is 1? You just see here, step time is 1, final value is 1. Final value means the amplitude of this signal, it is 1. So that's why it is appeared here as having amplitude 1, right? And step time is 1. That means after 1 second the signal will give you the output you will get, right? That means just zoom it here. Just zoom it here. Wait a second. Let me reduce this time, then you will come to know. 10. For 10 seconds I am running. Just see. Step time was 1. Because it was 100, that's why 1 second of delay, it was difficult to observe. That's why I have reduced the run time. So it is running for only 10 seconds, having an amplitude of 1 and the output generated after 1 second, because the step time was 1. You just, if you want to make it 0, you can easily make it 0. After that press OK and then run. You can see no delay is there. Initially at 0 you are having an amplitude of 1 second. If you change the output, that means 5, amplitude of 5 after 10 seconds. No, it is total runtime I have given as 10. So suppose after 4 seconds, right? Okay, run. As you can see, after 4 seconds the amplitude is showing here. If you want to add some other blocks, I am just showing you how to generate the model, or how to create a model. Some block is also there. If you want to add some other signals, if you want to give negative feedback, then from here you can easily take a feedback. As it is plus plus, negative, if it is negative feedback, then you have to make it plus minus, right? So likewise you can create a model. Feedback is there. If you want to put a controller here for any application, then you need to drag and drop a controller block here. PID controller block is also there. This is commonly used blocks, right? So likewise you can create a model for any process or any system, whatever you want to create. Then you can check the output here whether this whole system or model is working properly or not. Then you can apply it in your real-time process, right? So this is the basic things by using which you can generate or create a Simulink model, right? And one more thing, uh, while creating the models, the tools, whatever tools you are using, just go through these lists. Continuous is there, here you can find out integrator, then PID controller, likewise transfer function. These are all under continuous blocks. Then sources, sinks, these things. And mostly in commonly used blocks option you will find all these things, whatever is required. Mux is there, demux is there. Mux is used to if you want to plot more than one signal, suppose the output is like this, and if another signal is there which you want to plot along with this signal, then mux you need to include in between this before the scope. It is having number of inputs and single output. If you want number of inputs is here 2, if you want more than 2 you can change the number of inputs from this, and then press OK and you will get the output, right? So likewise we can easily construct a model, Simulink model in the MATLAB using those Simulink blocks or basic Simulink tools, right? So this is the overall brief description or brief idea, or you can say introduction about the MATLAB Simulink tools by which we are going to perform the further experiments in process control, right? So thank you.